This next lecture is concerned with it's a mini topic called air propagation, and it's the idea that if you make an error in a specific measurement during the experiment, it's how the error in that measurement propagates through calculations that it's used in, and so it's be particularly useful for you during experiments and during the analysis of your data. So we'll use an example here. We'll assume a cylinder with a height of 10 centimeters and a radius of 6 centimeters, and we'll use this to see how measurement errors can propagate through a calculation, in this case the volume, for example. So, like I mentioned, an error in the measurement of the radius or the height will lead to an error in calculating the volume, because the volume is dependent upon those two inputs. So there are two types of error we're just going to discuss. The first is what's called systematic error, and that's defined as the error caused by a measurement instrument or by the person operating the instrument. So it's basically built on faulty measurements, such as if a ruler is just miscalibrated or whatnot. So for calculating a value u, which is based upon some inputs that we'll call x, y, and z, the systematic error du is defined mathematically as follows, as the partial of u with respect to x times dx plus the partial of u with respect to y dy plus the partial of u with respect to z dz. So for example, if the ruler was miscalibrated by 0.1 centimeters, both the radius, the dr in this case is basically and the dh are basically where the miscalibrations are, the error associated with it. Both of those would be 0.1 centimeters. And for the volume calculation, dV, the error in the volume calculation is partial V partial H times dH plus partial V partial R dr. So when you plug those in, or when you first do the partial derivatives, dV becomes, it would be 2 pi r h dr plus pi r squared times dh. And so when you plug in the numbers, you get that the error associated with the systematic error associated with this particular volume calculation is 49 centimeters squared, or centimeters cubed. Sorry, that should be cubed. Now there's also random error propagation, and so this is error caused by unknown and unpredictable changes in the experiment. This is a more common use for error propagation. And since random errors can be either positive or negative, we look at du squared instead of du, seeing as that you shouldn't be able to have a negative random error. And then, whereas the definition for systematic error was the partials times all the dx's, dy's, and dz's, the definition for error with random error is what's seen below, and it's not too dissimilar, but what you'll find is it's a square root of the sum of the squares. So for example, if we were going to use do a calculation of u is basically the product of two measurements, x and y, we would find that the error or uncertainty associated with the calculation of u is the following from the partial derivatives, and I'll leave that to you to do the derivation on your own. So hopefully through this little mini lecture you've seen how error propagates, and you've learned the difference between random and systematic errors, and we'll be able to apply this to different laboratory exercises you'll do.